Hello everyone. Today I'm going to show you my Frankenstein power supply, which is a version 2.0. This used to be in a different plastic casing and it had a switched mode power supply instead of a transformer. Now if you have watched that video, you'll know that I used a boost converter to boost the voltage from 12 volt to about 35 volt so I can get at least 30 volts. This time I have removed that switched mode power supply from the DVD player and also that boost converter. Now I have a transformer and a bridge rectifier and that good old lithium-ion battery charger module. Let's unplug it from the mains and then take a look inside. You can see this is a tiffin box that had two sections, maybe one for the vegetable, the other for the paratha, and basically in there you can see a transformer that outputs about 18 to 20 volts. The mains comes in and from the switch it goes to the transformer. Here you can take a better look, and on the top section I have this bridge rectifier, and as you can see there is a lithium-ion battery charger module along with two potentiometers, which are the usual potentiometers changed so that I can control them with my fingers. Basically this is a 10-turn good potentiometer. I had another one but that one died for some reason, so currently I'm using this one. This is a very common single turn potentiometer. This one is 10 kilo ohm and this one is 1 kilo ohm, replacing the usual ones. Now that we have taken a look inside, let's shut it down and plug it into the mains. There it is plugged in. Let's turn on the switch. Right now it is showing 12.3 volts, and this button here cycles through the display modes. This shows you how much current you are drawing and then how much power in watt, and then there is a mode where it will keep switching between all four modes, and then it settles down again to the input. The input is right now unstable 24 to 25 volts, and then there is the output, then there is the current and the power and the cycle mode. So how much current can I draw from it? Well, I have tested that it can deliver up to 3 amps or less, maybe 2 amps. It does get a little hot. It gets a lot hot. The transformer and the module gets very hot, but it doesn't melt the plastic, so I think we are safe. So last time I wasn't able to give you any demonstration of the power. Here I have a 12 volt LED panel, very cheap, and I'm going to use just about 12 volts. As you can see, with this potentiometer it is harder to control. If I had the 10-turn potentiometer it would have been easier. Here I plug it in, and you can see it's quite bright, and this needs a heatsink or it gets hot. Now here I have an LED which I brought, and the seller told me that it was 12 volt, but I couldn't run it on 12 volt, and I went to return it, and the seller then told me that he mistakenly gave me the 24 volts, so I was unable to drive it for a while. Now let's try the 25 volts, and it takes up some current, and it's not that bright. It takes up a lot of current. If we can see that it is running at 24 volts and consuming right now very little current, only 10 milliamps. I don't know why. And while cycling it kind of draws more power. So let's go back to the voltage and test something else. This, I guess, since the markings have disappeared, I guess it is a 3.3 ohm resistor. Let's check it. Yes, it is a 3.3 ohm resistor. So theoretically, if I were to apply 3.3 volts, first let's limit the current a little and then apply 3.3 volts. As you can see, instantly the voltage goes down, but as I increase the current, the voltage will get stable and it will go up to that desired 3.3 volts. And right now, if we look at the current, we are drawing almost 1 amps, and that's 3.3 watts of power, give or take. Theoretically, if you were to put 3.3 volts across a 3.3 ohm resistor, then you'd get 1 amps flowing and 3 watts of 3 watts of power. Here it is, 3.3 volts being put, and it's getting hot. I guess this resistor is getting very hot. Yes, it is getting hot, drawing 1 amps and 3.3 watts of power. Now what else can we do with this power supply? Let's test one of these simple LEDs by limiting the current a little, and the usual, not 3.3, maybe just a little less, 3 volts. And it can take it, and this one takes about that 10 milliamps. We can also drive inductive loads such as this motor. This one I found inside some gaming controller. It's not in good shape, but it works. And this has a hammer on top of it, which basically puts the center of gravity in a different location, so you get vibrations. This is called this motor, this type of motor with a hammer is usually used inside those gaming controllers for vibration, and you can't really hold on to it for long. Now let's put the motor aside. I have another thing. This is going to be an ESC controlling this DVD drive motor with an Arduino. As we know, ESCs have this microcontroller eliminating feature where you can just plug the ESC power in and you get 5 volts stable power for your microcontroller. So I'm going to put about 12 volts here. And this will need a lot of current, so I'm going to give it a lot of current, and then by adjusting this tiny potentiometer we should be able to see some movement on this. To confirm the movement, let's put something like a sticker here. See, a nice sticker. And now let's use this potentiometer and let's see if it works. As you can see, I'm using the servo.h library, and you can see that the motor spins quite nice. The sticker just fell off. Let's put that aside. I was afraid it was gonna blow up or something. Now at this point we are drawing, let's see how much current, about 500 milliamps, but it's bottlenecking, so I'm going to give it some more, allow it, and that's 5 watts of power. And as you can see, the input has gone down significantly, because the transformer is maybe not capable of delivering such power, I intend to put a more robust transformer, but that's for a future video. So let's shut it down. Something smells. I don't know, maybe it's this motor. The motor is hot. It's quite hot now. As you can see, these BLDC motors have basically one permanent magnet and a lot of electromagnets. So that's about it for the ESC. Now, can we do something else with this power supply? Let's see. Here I have an ordinary mechanical pencil. This has a lead. We know these leads are made of conductive material, carbon. Let's turn the power supply on and look at the output voltage. Here it is, and resetting it, I'm putting everything to 0. So this power supply is able to deliver from 1.2 volts all the way up to 25 or 20 at least, but not less than 1.2 or 1.3. This is a offside of the power supply, but I don't think most projects would need such little voltages. So here, what we can do with these LEDs is that if we plug a power source across its ends, we can actually draw a lot of current. And what that does, you can see this is smoking now. This just gets too hot, and it is drawing about 800 milliamps. I hope my probes don't melt. Now what can we do with this? You can actually melt plastic with this. Let's try. You see? Plastic melts. You can like make something out of something. For example, if I wanted to cut this, it's like butter. As you can see, I'm cutting plastic like butter. Okay, that's enough. Okay. It will fall. There it is. And it smells. Let's shut it off. Yeah. So while that may be useful for some purposes, if you want to cut styrofoam or plastic or maybe acrylic, I don't know the melting temperature of acrylic, but you can definitely cut plastic with this, with such LEDs and a power supply. So maybe you can do a lot of things. The power supply is one of the most fundamental components, one of the most fundamental equipments you're going to need. So I am right now using this, but in future I hope to buy a better power supply, or maybe make one, make an even better one. So with all that said, I hope you like this video. If you have any inquiries, please leave it in the comments, and hope to see you in my next videos.